So in this tutorial we are gonna start using the toolbox in order to control Kuka robot. So before starting you have to have the Java application MATLAB toolbox server already synchronized to the controller of the robot. I have described the step in elaboration in a previous tutorial. Afterwards, you also have to have a network established between the robot controller and the PC that you are going to use in order to control the robot. Also, this step has been explained in details in a previous tutorial. Now, if you have those two steps already done, then you can continue with this tutorial in order to control iiwa from MATLAB using the Kuka Sunrise toolbox. So, first of all, in order to establish connection between the robot and the PC, we need to specify 4 things in MATLAB. First of all, we need to specify the IP of the robot. Then we need to specify the type of the robot, because we have 2 types, the 7 kilograms and the 14 kilograms. Then you have to specify the type of flange attached to the robot. Then at the end, the 4th thing that we have to specify is the transformation matrix of the tool center point of the effector with respect to the frame of the flange of the robot. So the idea is, if we do not have anything connected to the flange of the robot, this 4th variable is not necessary. But if you have an end effector that is attached to the flange, then if you want to control the tool center point of this end effector, then you have to specify a transformation matrix, and you have to tell the Kuka Sunrise toolbox that you have this tool attached and that you want to control the tool center point of the end effector when you are sending motion commands to the robot. So first of all, you have to open MATLAB, then you have to change the working directory of MATLAB into the folder MATLAB client that you can find inside the Kuka Sunrise toolbox folder. After doing so, we have to specify the 4 variables that I have already spoken about, which are the first, the IP of the robot, then the type of the robot. Now, in order to specify the type of the robot, all you have to do is to write the initials KST, which are the name of the class of the toolbox. Then you have to type dot, then you have to press the tab. When you press the tab, you can see all of the enumerations that are provided by the KST class. And what I want to use is the type of the robot. Here in the lab I have this 7 kilograms robot, and I'm gonna choose the enumeration LBR7R800. Then I need another argument that shall hold the type of the flange that is attached to the robot. Here I have the media flange touch pneumatic, so I'm gonna choose it. So again, you have first to type KST, then you have to type dot, then when you hit tab, you can see all of the enumerations that are provided by the class and then you are gonna choose the type of flange attached to your robot from this list of enumerations. Afterwards, as I said, if you look here at the robot that I have, we can see that I have a tool changer attached to the flange of the robot. And the tool center point of this tool changer is 45 millimeters away from the origin of the frame of the flange. So I'm gonna define this matrix. The first row is 1 0 0 0. The second row is gonna be 0 1 0 0, because the third row is gonna be 0 0 1 0.045, and the last row is gonna be 0001. So the fourth column is the displacement x, y, and z of the tool center point with respect to the frame of the flange. And here I have the tool center point placed 45 millimeters in the z direction of the frame of the flange. So if it is 45 millimeters, then it's going to be 0.045 meters. The transformation matrix here, dimensions of the displacements shall be in meters. Do not forget, they should be in meters. And then the first 3x3 submatrix of transformation matrix is the rotation of the frame of the end effector with respect to the frame of the flange. But I have the frame of the effector and the frame of the flange basically parallel to each other's. So the rotation matrix is the identity matrix. So I have 1 0 0 0 1 0 0 0 1. Now, after I have defined the IP of the robot, the type of the robot, the type of the flange, and the transformation matrix, the tool center point of the end effector with respect to the frame of the flange, I can right now instantiate the object iiwa from the KST class. I can do so by calling the constructor of the KST class. Then I have to pass the various arguments that I have defined before. And here we have the iiwa object. Now, using the iiwa object, you can connect to the robot. So what you have to do right now is you have to go to the teach pendant of the robot, and you have to start the application MATLAB toolbox server. After starting it, you have 60 seconds to connect from MATLAB. So you have to go back to MATLAB and you have to write iiwa.net establish connection. So what am I going to use is I am going to use the method establish connection, which establishes a connection between the robot and between the external PC. Hit enter, and connection has been established. Now, if you look at the screen of the teach pendant of the robot, you can see that the program has already typed the displacement of the x, y, and z of the tool center point with respect to the frame of the flange. Also, it gives you the ABC fixed rotation angles of the frame of the end effector with respect to the frame of the flange.